Okay, so let's have a look. It's a structure to support a roof, and we've got four wooden beams. The four wooden beams being the three sides of the big triangle plus this extra side BC there. Now it gives us some measurements. I'll write them on. AB is 6.5, so that's 6.5. BC is 4.7, and that's the same as BD. So that's actually an isosceles triangle, that triangle BCD, and angle BAC is 35. Right, now find to one decimal place the size of angle ACB. Now angle ACB is this angle here. So we've got this side and the opposite angle, and we've also got the opposite side, so I think we can use the sine rule to do this. So sine rule, the sine rule tells us that 4.7 over sine 35 equals 6.5 over the sine of angle ACB. Now, by rearranging this, we get an expression for the sine of ACB as sine 35 times 6.5 divided by 4.7. Okay, and if you work that out on the calculator, it comes to something like 0.79324. Right, so that's the sine of the angle. So let me write it again up here. The sine of the angle that we're trying to find is equal to 0.79324 ... Now what we need to do to find ACB then is to do the inverse sine, or the arc sine, of that angle. But the problem is this. If we think about what the sine graph looks like, then if I draw a sketch, whoops, it's going to look something like that. Not perfectly drawn, but, and that there is sine, call it theta, and that there is theta. Now that's 180 degrees, that's 360, and that there is 90. Now what that means is, if we've got, and of course the top value of sine here, you should know, is 1, and it's minus 1 on the bottom here. But if we've got a value 0.79, that value of sine is kind of, it's about here, isn't it? So the thing is, between 0 and 180, there are going to be two possible angles it could be. One here and another one here, right? So when we use the calculator to find the inverse sine of 0.79324, that will tell us that the angle is 52.5, right? But what that's telling us actually is that this angle here is 52.5. If you look at the diagram, you'll see that the angle that we want is actually obtuse. It's bigger than 90 degrees. What that means is the angle that we want for ACB is going to be 180 minus 52.5. It's this angle here which I'll put a star by, which is, I mean, the graph is symmetrical, so the calculator tells us that this first angle is 52.5, but because we want one that's bigger than 90, because the angle we can see is obtuse, that means we've got to do 180 minus 52.5, and that gives us the angle ACB, which is 127 8.5 degrees to 1 decimal place. Okay. Right, now part B. Find to the nearest metre the total length of wood required to make the structure. Right, now look, we've got 6.5, we've got 4.7. We know that this bit in the middle is 4.7. What we're going to have to do is to find the length of side AD. And that's the remaining measurement that we need. And we can do that using the sine rule, because we can quite easily work out what this angle here is, can't we? Because well, this angle here that we've just worked out, ACB, is 127.5. This angle here is then going to be 180 minus 127.5, which is 52.5. That's that one there. But because this is an isosceles triangle, the triangle BCD, it means that this angle here is also going to be 52.5, okay? Which means that the angle here, I'll shade in red, this angle here is just going to be 180 minus 35 minus 52.5, which is 92.5. 92.5 degrees. And then all we have to do then is use the sine rule to find AD. So part B, right, we're going to have AD over sine of the angle opposite, which is 92.5. So AD over sine 92.5 is going to be the same as, and we can use either of these actually, but I'll use the 35. So it's the same as 4.7 over sine 35. So 4.7 over sine 35. By rearranging this, we get that AD is 4.7 times sine 92.5 divided by sine 35. And when you do that, I think you get that AD is 8.19 meters. And therefore the total wood has got to be 8.19 plus 4.7 plus 4.7 plus 6.5. So plus 2 lots of 4.7 plus 2 lots of 4.7. It's getting a bit messy, sorry. Kind of do that. Plus, what was the other one? 6.5, I think. Yes. And that should give us the total wood. And yeah, if we do that, put it into the calculator, and we get the answer 24.1 meters for the total length of wood required.